Before we dive into this tutorial, let's make sure you have the necessary prerequisites. To follow along and get the most out of this Python for Beginners tutorial, you'll need to have two things set up, Python and Visual Studio Code. You should have Python installed on your computer. We'll be using Python 3 in this tutorial. If you don't have it installed already, you can download it from the official Python website. Follow the installation instructions for your operating system. To verify that Python is installed correctly, open your terminal or command prompt and type python -- version. Let's check what I have. On my system, I have Python 3.11.2, which is the latest version of Python. Although you can write Python code using any text editor, I strongly recommend using Visual Studio Code. To download and install VS Code, visit the official website and follow the installation instructions for your operating system. Once you have VS Code installed, you'll also need to install the Python extension for VS Code. To do this, open VS Code. Go to the extensions view by clicking on the square icon in the activity bar and search for Python. Find the official Python extension by Microsoft and click the install button. If you want to see the recommended Python extensions for VS Code, check out my other video here. With Python and Visual Studio Code set up, you are now ready to follow along. First, let's talk about variables. Variables are like containers for storing data. In Python, you don't need to declare a variable type. Just assign a value using the equal sign. Let's create a variable called name and assign to it the value Alice. In Python, if you define something in quotes, it means it's a string. Python has different data types, such as integers, floats, strings, and Booleans. We can use the type function to check the type of our variable. We can see that it has a type of str, which means string. Now is a good point to explain the different types that a variable can be. In Python, primitive types, often called basic or built-in types, are the simplest data types that provide the built-in blocks for constructing more complex data structures. There are four main primitive types in Python: integer, float, string, and Boolean. We'll check the non-primitive types in a bit. Integers are whole numbers, either positive or negative, without any decimal points. For example, 42, -7, or 0 are integers. Floats represent real numbers with decimal points. They can be written in either standard or scientific notation. For example, 3.14 minus 0.5 and 42.42 are floats. As we've seen earlier, strings are sequences of characters used to represent text. In Python, strings can be enclosed in a single or double quotes. For example, hello, world, and Python is fun are all strings. Booleans represent true or false values and are used to evaluate logical expressions, which we are gonna see later. In Python, the two Boolean values are true and false. These primitive types are the foundation for working with data in Python, and they can be combined to create more complex data structures like lists, dictionaries, and tuples. These types are called non-primitive types, and this is what we are going to see next. In Python, non-primitive types, also known as data structures or composite types, are used to store and organize more complex data. Unlike primitive types, they can store multiple values or elements. Let's discuss the most common non-primitive types in Python, which are array, list, tuple, dictionary, or sets. Lists are ordered mutable collections of elements. They can hold elements of different data types, including other non-primitive types. Lists are created using square brackets, and elements are separated by commas. Tuples are similar to lists, but they are ordered and immutable, meaning their elements cannot be changed after creation. Tuples are created using parentheses, and elements are separated by commas. Dictionaries are unordered collections of key-value pairs. They allow you to store and access values based on their corresponding keys. Dictionaries are created using curly braces with keys and values separated by colons and key-value pairs separated by commas. Sets are unordered collections of unique elements. They don't allow duplicate values and are often used for tasks like removing duplicates from a list or performing set operations like union, intersection, and difference. Sets are created using curly braces with elements separated by commas. These non-primitive types are essential for working with more complex data and performing advanced operations in Python. By understanding and combining both primitive and non-primitive types, you can create powerful and efficient programs. Let's create some examples. For the examples, we are going to use the input function, which is a built-in function to get input from the user terminal. And we can see the output. Hello Costa, you are 32 years old. Next, let's explore operators. Python has arithmetic, comparison, and logical operators. Let's sum up two numbers. We have to cast the output of the input function to float because the output of the input function, as we can see, is a string. And the result is 22 as expected. Let's create an example for if statements. They allow us to make decisions based on conditions. Let's create a program to check if a number is even or odd. Again, we have to cast our input to an integer because, as we've said, the output of the input function is always a string. The percentage operator is called mod, which is short for modulo. Modulo is an operator that returns the remainder of any number divided by another. In our case, if a number is even, then its modulo is 0 because if we divide that number by 2, there's no remainder. 4 is an even number, so our code works correctly. Our program outputs the number is odd, which is the correct result. Let's move on to for loops. They are used to iterate over a sequence like a list or a string. Let's write a program to print the elements of a list. Let's see what we are doing here. We have a list, and then we iterate over each element in my list. And this for loop notation, what we'll do here is to go over each one of these elements in the list, assign this value each time to this variable called element here, and then inside this for loop, we can use this variable to have some logic. In our case, we're just printing the element, and we can see here that it says 1, 2, 3, 4, which is the elements in our list. Another type of loop in Python is the while loop. It repeatedly executes a block of code as long as a condition is true. Let's create a countdown timer. Let's see what our program is doing here. First, we assign a variable called count, and we set it equals to 10. Then, using the while keyword, we are checking a condition. In this case, we are checking that count is bigger than 0. Then, we are printing the count variable, and after that, we are decrementing count by 1 each time. After this while loop ends, we just print blast off. Let's see. As expected, we see 10, 9, 8 until 1 and then blast off. Next up, we have lists. They are ordered, mutable, and can contain different data types. Let's create a list of favorite fruits and add an item to it. We have a list with 3 items defined in line 1. Next, using the .append function, we can append an additional element in our list, and then we'll just print the list. So we're expecting to have orange in our favorite fruits. Dictionaries are another useful data structure in Python. They are unordered, mutable, and store data as key-value pairs. Let's create a dictionary of countries and their capitals and retrieve the capital of a specific country. Here, in line 1 until 5, we are defining our dictionary. Next, we are asking for the user to give us an input, a country, basically. Next, on line 8, we are trying to retrieve the capital of a country. And on line 10, we print the result of the lookup in our dictionary. The capital of USA is Washington, D.C. Now, if we add a value that is not on our dictionary, it should give us the not found, which is the default value of the get function. The capital of Germany is not found, which is the correct result because we don't have Germany in our dictionary. Tuples are similar to lists, but they are ordered and immutable. They can be used to store multiple values. Let's create a tuple of x and y coordinates and calculate the distance between 2 points. First, on line 1, we define the first point. On line 2, we define the second point. And on line 4, we are creating the calculation for distance. So point 2 of index 0, it's this value here, and point 1 of index 0 is this value here. And this is the calculation. And on line 5, we just print the result. Here, the .2f, it means 2 decimal points. So the distance between the 2 points is 3.16. Now, let's wrap up this tutorial with some small exercises to test your understanding. Create a program that calculates the factorial of a given number. Write a program that checks if a given word is a palindrome, reads the same backwards as forward. And exercise 3, create a program that sorts a list of numbers in ascending order using the bubble sort algorithm. If you would like to check the source code of these 3 exercises after you complete them, you can head over to my website, costapiy.com, and you'll find a blog post using the same title as the YouTube video, and then you can check out the source code and see if your solution is correct or not. And that's it, folks. Congratulations on completing this Python for Beginners tutorial. We hope you found it helpful, and we encourage you to practice and experiment with what you've learned. Don't forget to like, share, and subscribe to our channel for more awesome Python content. Happy coding!